Okay, guys, so we'll be doing the RSA factoring challenge, and this particular task is kind of a bit hard to get all your full mark. Okay, so I did it somewhere and I got 140% out of 200, which is nice. There are different approach to this task. Okay, so depending on which one you would be using. So I think this challenge has just two tasks, and in the two tasks, the first task I'm going to be using two methods, and then the second one, which is task one, I'll be using just one method to solve it. Okay, so I will just go ahead and run the I don't know if I should start from the second one and then the first one. But the problem with it is that the first task says that our program should your program will be killed after 5 seconds. So the first method I'm going to be using to do this guy, the program will still be running after 5 seconds, so it would limit the scores that we're going to get. So the second one would actually operate within 5 seconds, but even as at that, we'll still get like 50 something percent for this first task, and the second one probably 20 something percent, which overall gets 140% if you are doing it on your first deadline. On your second deadline, probably you'll be getting 70% or so. All right, so I checked everywhere to see if people managed to solve it, but I think it's not meant to be totally solved, right? So everything, the algorithm was right, what I did was good, but anyway, you still get some probably few reds or many reds anyway. All right, so let's get started. So before I dive into this task, right, I don't know if you find it hard understanding this challenge or this task. It's a very simple, interesting, and lovely task. It is so sweet, and it's one of the best topic ALS has ever come up with, right? So it talks about the encryption and decryption of messages of different things on the internet, right? So if you are familiar with WhatsApp, you would know that WhatsApp is a messaging app that also has this decryption and encryption. Yeah, to what's it called? Is it 2FA? Right? So it's a decrypted and encrypted platform, which means that only the sender and the receiver can view a particular message, not even WhatsApp. So how this works is that when a message is sent, right, the server uses two long prime numbers in order to decrypt and encrypt these messages. For example, if I'm sending this text to someone else, right? So my computer will generate these two large prime numbers. It will multiply them together to produce a semi-prime number, and then uses the semi-prime number and then calculates a particular number to decrypt and to encrypt and to decrypt it. Encrypting it meaning that it's going to change this guy, probably multiply each convert this guy to ASCII value, multiply it with a particular decrypted value, encrypted value, right? Maybe multiply it by 6 and then decrypt it back by probably dividing by 6, but not dividing by 6, divided by something else. I'm just saying dividing by 6 will give you back the number, right? So it works in a way that when you even multiply with another number, probably 11, it's going to give you the RSA, right? Factoring telling to the person. So the good thing about it is that it's only the system that have this number. It's only you that you are reading it, and that has that order number to decrypt what the person has encrypted. Okay, so I'll put it in another way. It's just like I gave you a padlock, just a padlock, and I have a key, and I said, okay, send your message inside this box and padlock it. Only me have the key, so I'm the only one who can open the key. So in order to work out this padlock and key, they use a prime number. That's what you should know. And I think with this small analogy, you would understand it when you read the material. Okay, so they use it in HTTP security and all that, right? So the SSL security and all. Okay, so that's basically what it does, and that's where it talks about the how HTTPS provides security. Yeah, and then what is RSA? RSA is just the type of algorithm used in order to decrypt and encrypt, and it's a name from 3 different people that came up with the idea, right? And then I told you it uses prime numbers, so that's why you need prime factorization as well to understand what prime numbers are and how it's being used. And the security of it comes with the fact that it is very hard to get the factor of a very large prime numbers, right? Semi-prime numbers, right? I think that's the word. Yeah, when you multiply 2 prime numbers together, you get a particular, I think that's semi-prime number made of 2 prime numbers, right? So that's it. You can choose the language of your choice. So in order to do this task, you can use C, you can use Python, you can use your bash script. Okay, so to solve this question. Okay, so this tag 0, right? There's a way to solve it using Python, right? But the thing is, I think you would still have your reds, but you get probably a bit much lesser compared to this second method I'll be showing you. So the first method to solve this tag 0, I'll be putting it on the description so you can try it out. If I have time, which I'm sure I might not have time, I will go through it, the other one. But for now, let me just go through the one that will give you more mark, which is the bash script method. But the second one, I'll be using Python to solve it, which is similar to the first one that I'll be dropping on the description, okay, of this video. All right, so if you look at it, right, he said factorize as many numbers as possible into a product of 2 smaller numbers. That is, you have a number, right, and then you have to divide it into 2. You understand? For example, you have 4. When you are factorizing it into 2, it's 2 times 2, right? If you have 14, 2 times 7, right? So basically that is as simple as that, right? Like I said, he's just multiplying 2 prime numbers. That's how RSA works. It works with prime numbers, how hard it is to get the multiple of 2 prime numbers and all that, right? So basically they're just trying to make you kind of crack an algorithm, right? That I think if you read it well, there's a part that talks about all those rubbish. I think in the beginning, something like that. I can't remember where I saw something like that. Yes, yeah, we have sniffed an unsecured network and found numbers that are used. So they found those numbers already that are used to encrypt a very important document. So once you get the numbers, it's easy for you to decrypt those, like I told you in the beginning, right, where I use 6 and 11 also. So they've gotten those numbers. With that, you can just multiply it and get your answers yourself. So I think that's what, when you read it, you definitely understand it, and it's a very nice topic to understand, to learn, right? So yeah, we say factorize as many numbers as possible into a product of 2 smaller numbers. The usage is factors, right, and then a file will be passed. So where file is the file containing natural numbers to factorize. So we'll have the factors, and then we'll have the numbers you want to factorize. 1 number per line is inside. So inside this file, there's a number you want to factorize, each number per line. You can assume that all line will be valid natural numbers greater than 1, so you don't need to stress yourself. You can assume that there will be no empty line, so everything will contain something. and no space before and after the valid number, so they don't want to stress you. The file will always end with a new line. Okay, the file will always end with a new line. I'll use my mouth to kind of explain the one I will be putting on the what's it called, on the description, because that's easy and you should try that one because you will understand it. This second method I will be doing is not easy to comprehend, but it's simple and short, right? So that's what I'll be using, and it is much more faster compared to the Python that we're putting on the description. All right, so the output should be n, right, which is the total number, that's the number you want to factorize, equals to the factors. These factors, like for example 14 equals to 2 times 7. You understand? Okay, so one factorization per line. P and Q don't have to be a prime numbers. So now I said prime numbers are numbers that can divide itself, right, and 1 also. So P and Q does not have to be prime numbers, so we can have 2 for a number called 4. The factor does not have to be a prime number. It can be 2 times 2. If you have like 8, it could be 4 times 2. It could be 8 times 1. 8 times 1, right? So 8 is actually a prime. It is not a prime number, right? So it doesn't have to be a prime number. So it's, see example. You can work on the number. I thought someone is coming. Sorry. I still feel someone is coming to knock the door and distract me. You can work on the numbers of the file in the order of your choice. Okay, your program should run without any dependency, right? You will not be able to install anything on the machine we will run on your program on. Time limit, your program will be killed after 5 seconds if it hasn't finished. That is within 5 seconds, so it has to be something very fast. You get 5 seconds. If it hasn't finished, then it will be killed. And to get all this stuff, most times your program might just spend like 12 seconds or something like that, so it's not going to make you get your full mark. So you have to use something, probably a C language that is more faster. You understand all those stuff. Yeah, so push all your script source code into your repository. We will only run your executable called factors. So we need to just have an executable file called factors, right? So it has to be a script like stuff, right? So if you look at it, we have the test file, right? These are the test files up to this point. So we are testing all this line by line 4. And then if you look at, we have the test file is in a file called test00. So this is the file, and then this is our file that we'll be creating. So we have our functions that we'll be creating. So it has time to show that, to tell us the time that it will finish. Anyway, we have the factor which is being executed here, and then the file passed to it. So it has to receive a file in your code. You have to write it in a way that is going to read in the file and then execute whatever, find the factors to this. If you look at, they just use 2 to divide most of it, right? And the one that can be divided by 2, they will use 3, and then use, 2 would go for anything even, but anything odd, 3, and then 5, and then 7 would increase by 2. So that's what they did. So what they will first do is check if is a modulus of 2, right? Check if is a modulus of 2. If it is, then just divide it by 2, and then the remainder would be what will be the other factor you get. So for example, 12 divided by 2, it remains 0, so it is a factor of 2. So we just do 12 divided by 6, which is 12 divided by 2 rather, which is 6, and then 6 times 2. So they used 2 majorly, and then when they got to this point, this one end with 5, you know that it's a multiple of 5. So they will try 2, and they say that it's not, it won't go. You try 3, it won't go. Then you would continue from that 3, you increase by 2, so to try all the odd number, because if you try 4, anything that go in 2 will also go in 4, so you just be trying even numbers. So you try 3, after 3 it doesn't go, you try 5, and then after 5 you just divide it by 5, and then get the remainder. So this one they try 3 3 3. Let's go down 3 3, and yeah, they try, I'm sure they tried 3. 3 won't really go yet, right? So they tried 5, it won't go, and then they tried 7 will go, and then divided by 7 and stuff like that. And then here they tried this one. Can you see this one is kind of high? So they tried, I don't know, maybe 9 different things, and maybe increase. This one will really take your time. Look at this, is a long number, so to get the factor of this one might be very high. So they tried this anyway, and it went through. And then the time they used here would help us calculate how many time it used. Look at this one, use 0.001 seconds. This is super fast, man, crazy. All right, so let's just create our GitHub repository and do something. So for the first code, so basically kind of what I explained, I'll be putting it on the comment section, so go through it and you can learn from it. Anyway, so I will try the bash script, bash, and then for this one, so it will be faster. You might not quite understand it, but it's going to be simple. I'll try and explain, and it's short. Okay, so the first thing, we're going to create our repo, right? It's called RSA Factoring Challenge. So I'll copy this, I'll go to my GitHub and then create a new repo, so you can follow Olaguru. And let's paste this. So we've created this, we don't need, make it public, so we don't need anything. So create the repo. So we need to clone the repo as well, right? So I'll copy this guy, rise to, so ls, we don't have much here, so I'll say git clone, right? But before I git clone it, I'll need my token, access token. So to get my access token, I don't need to go anywhere. I think I can have it here. So I will cd into my ALX higher level, and then ls, and then la, and then I'll cd.git/config, no, it's not cd, I'll vi into it directly here. So this is my access token. I'll be changing this access token because it's not quite okay to have an access token open like that, right? So let me just copy the full guy here, and then I'll just change the names of the stuff. Okay, so I'll copy this guy, copy. So what you need to do next is exit this one. All right, so we'll clear this, and then we'll say git clone. I'll paste this guy, and then Olagu, and then what is this guy's name? So I'll just copy this guy like this. Do I need this .git? Can't remember. So let's copy this, and yes. So do I need this .git? I'm not sure. Let's do this here. So we have it. So cd RSA Factoring Challenge ls. So clear. So I have my git. Okay, good. Anyway, so what I'll do is I'll create my readme with md. I'll say RSA factorization, right? Factoring challenge. So majorly is about factorization. Is as easy as ABC when you understand it. All right, so we have that. So the next thing we will need is we'll need our factors file. Okay, so the factors file would now be the one that will have it. Then we can have a test file to test it, and then we'll push it. So I'll vi the factors. Okay, so I'll do that, and then we'll write our script. So this one now, what we're going to do is I'm going to write my shebang user. So I'm writing a bash script, bin bash. Okay, so the first thing we want to do, like I said, this one is kind of complex, but it's shorter. Yeah, so we'll have a file. Okay, so this file is like a variable. The variable will collect a number, right? It's going to collect it's going to store an argument that will be passed, which is the file, right? It's going to store it. Then we'll go to the next line. We'll say wow, and then read. So this read will read the numbers that will be inside the files. Okay, so while this, and then our semicolon. So we'll use do this. Okay, so while this do, and then we'll have our factors, right, to be equal to, we'll have our $sign. So this one is quite easy because we have a command that comes with a bash that helps us find factor. So we say factors. Now we are creating another variable called factors, and factors will find the factor of the number. Okay, so we are reading the number from a file. So it's kind of complex, but don't worry, just understand what we're doing and try it, and then you get it. But the second one I'll put on the comment section is quite easy. Okay, so what I'm doing is I'm reading from the file, right? File, this guy will save what will be passed to file, while, and then this one will read numbers from the file, right? So it's going to store the factor of the numbers read, okay, into factors. Okay, so that's just it. It's going to store, it's going to just factorize it straight. Okay, so it's factorize it straight, and then we can then echo it. You know what echo does? It prints back to the screen whatever you paste, right? So we echo, and then the pound, and then we'll have numbers equal to $sign equal to $sign, and then so what we do next is we'll echo the number, right? You look at, we echo the number equals to 7 times 7, right? Okay, so we'll echo the number, right? So what I'm doing is now I'm storing the outputs here, right, into numbers. Okay, $sign and this. So no echo, and then this into these numbers, the new number now. Okay, so we're echoing this, and we'll say this, and then numbers, okay, divided by this, and then curly braces, and then factors at 1, yes, and then times $sign factors 1. I think this is all, and then we are done, and then $sign file. Okay, so basically this is what we want to do. Okay, so what we do is we say number equals to, right? And then we say the first one, which is numbers, right? The number, right, divided by the factor that we got, right? So divided by the factor that we got. So if it is like 2, the first factor, right? So this one will give us the latter, the bigger part, right? And then times, this one will just show times, and then what the factor of the second one is. So I think this one should be index 0 and this one should be index 1. Maybe I'll try it first. I can't remember if that's what I should do, but I think it should work this way. Okay, so let us test it and check. So for now, ls, and then I'll change my mode of u plus x for factors. Okay, sorry. All right, so I'll put the other method, which is quite easy. That one is normal math, you understand it, it's quite simple, just like I explained it. But this one I'm using bash script, so it's kind of a bit complex, just a bit. All right, so the factor function comes with it, which of course find the factor itself, so it makes the time less. So let us cut the test file. So should we put it the way they put it? Let's put it. So vi cut. So I think this one will create a test file for us as a file. Okay, so vi this to create a folder and then create a file called test00. Okay, so we can paste what test00 is, which is this, sorry, which is this, and then we'll copy and then paste it. So we'll exit it, quit it, please press enter or type command to continue. Okay, okay, sorry, WQ override. I think because of the way I created my stuff is giving me issue. I've forgotten, I think override. Press enter, you can't open file. Can't open file for writing. What should I do? Okay. Yep. Let's see. You created it. You didn't create it, right? Okay. So what I'll just do is let me just create the test file. I'll create a test and create this guy. Test as well. Or then just make directly tests. So let me vi that guy again. Let's vi this guy and this guy. Let's try this time and see. So it works now. Okay, so that's what I did. Alright, I hope you get what I did there. So now let us test it. We just say time and factors and this. So copy time factors. So we tested the first one, right? And the time is small. I don't know. Just the first one is testing. Just the first line. I don't know if I'm doing it the right way. Maybe I missed something. So I tested the first one actually and it worked. So Let's see if I didn't do something right, or is it testing? No, the first one. So bi, or should I do? Let's see. Bi my factors. Well, I think I did it right. While with numbers do factors equals to factor numbers. Okay, I think I did mistake here. Yeah, numbers should be here. So let's try again. Okay, so it works. So it worked, and yeah. So this one is much more faster. If I do the other one, it will take time before it works. It will take time, absolutely, take time. Look at this, it gave me the answer straight. So that one might take up to like 10 seconds or 8 seconds or so. So, but that one is much more explanatory. So basically that's it. So let us git add and see how many checks we get. So git add the readme, and also let's just git add this one first so I can give it a good commits. So I'll commit this and call it readme, and then let's git add the second one, which is factors. Okay, git add, git commit, factorize without precision. Right. Okay, and then let's push all these guys. So I'll push it and then let's test it. So to test it, check our code. Okay, I'm so sorry, my audio stopped in between. I'm so sorry, it stopped in between, so I just continued it back. So we just tested this guy, and yeah, see what we got. So it's not quite too bad, but not too good, but it's better, I can assure you, it's better. So let's ask for correction and we should see something. I was robbed recently, so my other device for recording has been stolen and everything, so I just got new stuff, so it wasn't up to what I was using before. So manage my errors and all that, so it will get better over time. All right, so while that is going, we might get some scores. Yeah, we got 25, but actually you'll be getting like 51.this%, right, if you do it on the first deadline, because this one is like over third deadline or so. Yeah, so that's why we're getting that scores. So the other method, I'll be dropping it below, so just check it out and yeah, take your time. So what we'll be doing next is we'll be doing the other one, and which is the RSA. So this one will be using much of what's it called, of Python to solve it. The RSA laboratory states that for each RSA number n, there exist prime numbers p and q such that p blah blah blah. The problem is to find the two prime numbers. So it's just like the one we did earlier. We're still finding two, but now we are finding prime numbers, not actually is it prime numbers? Yeah, the prime numbers, right? I want to know if it is prime numbers or just any factors. So the RSA states that for each year, the tax is same as tax 0, except that p and q are always prime numbers, so they have to be prime number. There's only one number in the file you can, how far you can go in less than 5 seconds. So we stay after 5 seconds limit to solve all this stuff. So I have the call. Person is distracting my recording. Sorry, someone just disrupted my recording. So let's continue. The RSA laboratory states that for each RSA number n, okay, I think I've said all this, and let's just do what we need to do. So for this, I'll just be creating a file called RSA. So okay, so as I was saying, we're going to create our script, and we'll have it, shebang user bin python 3. So I would say with, or let's say from, we have to first import our argv in order to read file. Okay, so from system import argv. Okay, from system import argv. So with open, so we want to open the argument argv at index 1. So we can use as fd or as f. So what we are doing here is we are opening the argument that we passed, okay, or the file that we passed as f. Okay, so we are opening it as f. So we've opened it, we've opened the first argument, we've collected it. So we'll say for line in f, so which is the first argument, right? Enter. Why is this thing not working? Okay, I think, okay, because I didn't use .py. Anyway, that's what we're giving RSA alone, so no need for .py. So with open arg1 as f for line in f, so we'll say num. I could use .py and then remove it later because it's not giving me my correct indentation and it's affecting me. So move RSA as RSA.py. So we are RSA.py. So it's giving me that color now. So what I need to do next is go on insert mode. So I'll create a variable called num for line in. So each line we want to read it in this, and we'll say number equals to, we'll convert each line to integer. Okay, so convert each line to integer, and then we'll save it in number. So line is not a number. Okay, so what we'll do then is we'll print. Okay, we'll print, and then we'll say we'll print this guy %d equals to, and then dot format. Sorry, no, yeah, something like this. Okay, so so we want to print the number and then comma and end it with no space. Okay, so what we did is we opened the file, right? We opened it, we saved it as f, so f is now the file. For line in file, that's each line of the file, then we'll save whatever is in line into num, and then we'll print the number first. We printed the number without a new line. Okay, so we printed the number without a new line. So the next thing we are going to do now is, after printing the number without a new line, then we'll say if, remember we only printed what the number is out, right? So if num, right, percent 2, this is like what I was telling you, equals to, if the number is divisible by 2, right, and this, then you should print what? Print, remember it has printed the number, so you should print let's have this and say you should print the number times 2. I'll show you what I'm doing here. Format, and then this one will be num divided by an integer 2. Right, so let's do it this way. So what I'm doing is, if it is divisible by 2, remember it has printed the first number, right? Where is it here? It has printed this, right? And it has printed equal to, so it has printed 6 equals 2, so we need to get 3 and 2. So we check if it is divisible by 2, right? It is. Since it is divisible by 2, then what we'll do is, the first number will now be 6 divided by 2, right, which is 3 times 2. That 2 will be there permanently. So that 2 that will be there permanently is here, and then what will be before there is that number divided by 2. So I use this double because I want to divide it. I don't want full stop to be there. It's just an integer division, right? That is why that double slash is there. So I think a single slash will still work in this position. All right, so, and then would continue. Okay, so we have now a loop if in case it doesn't work. So for I in range, and then this time around we'll say 3 comma num, and I will explain why this, and then comma 2. So what I'm doing here is that I'm saying now we want to go from 3 to the number, right, and increment it by 2. Like I was saying, we want to check for odd numbers. Since 2 can go in every even numbers. Now odd numbers will be from 3 and then increase by 5. We want to check if they are divisible by all these numbers up to the number itself, which the number will not be among, right? So the next thing we'll do is then we'll say if num, right, percent I is equal to 0. Did you get? That is, if our number modulus, what's I will start from 3, modulus 3 is equal to 0, then we'll change the format. If not, it will go again, modulus 4, modulus 5, because it's increasing by 2, like that. So we want to check for all these guys. If it is, then the factor now will now be equals to the number divided by I, which will be 3 at that point, right? If not, right, and if it's still, if it's still, then we'll have 4, and then we'll have j in, we'll have another range, same thing, 3, and we'll check for the factor again if it can still go 3, and then for factor, and then comma 2. We'll check for the it if it is divisible again. So if I hope I've not pressed this guy too much. Where did I put this guy? Yeah, so if factor %j, that is if the factor percent whatever 3 here, we want to divide it again, is 0, or j itself is 0, then it should break. If not, you should print if not, you should print from here. If this, right? So if this happens, you should do this and then check for this inner one. If not, you should print what we have, our string dot format, and then you should print the same thing inside, this times this, which is the factor times what our I will be, times I, and then at the end it should break. So basically this is what should work for this second one, and this second one will have probably 10% when we're done. So let's clear it. Let us let me just chmod u plus x, because it's a script. RSA, remember I have to change the name, move RSA.py to RSA back. So I'll git add RSA git commit RSA challenge and git push. Okay, so I hope this one works a bit. Okay, let's see. Oh, I think we did something wrong then. So this didn't work at all. Let's check again. So we must have done something wrong. VI RSA. Yeah. User being Python 3 from import arg with open. I think this indentation is too much. So that happened when we were still, this indentation is too much, so I'll just reduce everything by 1. So 4, and then this one, I think this one is okay. I think is the indentation problem that we have here. So for line in F, so let us try this first, and if this doesn't work, we'll check again and see what we did wrong. So git add, git commit, git push. So let us check again. That was when I was trying the other one. Oh man. pray it works. Okay, not yet. So let us check again. So from 6 with open arg v1 as f for line in f, number equals to int line, and then print, and then %d equals to, and then format number comma end, yes, and then if num %2 equals to 0, print *2 from unknown divided by 2, and then continue. And for I in range 3 num2, and then if num %I equals to 0, factor equals to num1 num I. For j in range 3 factor 2, and if factor %j equals to 0 or j equals to 0, then break, then print this guy, format factor I, then break. Yeah, I think this is correct. This should be correct. So I don't know what we're doing wrong here. Yeah, so this should be correct. Is there a way to test this guy? Let's test it. So let us vi this and put 6. So this one is 1 by 1. So let us put 6 there. So let's test it. So if you get this, okay, yeah, so this syntax 12, we have this instead of this. So let's see, where is that? 12 somewhere here. Yeah, this guy. So I was so used to C, I use that instead of this. So that's why testing is important. Yeah, so git add RSA and git commit challenge and the push. So let us check now. Okay, be fast, bang. Why the waste of time? Should we reload it? Let's reload it. Reload the page and reload the page and try again. So let us test again. Still loading. Okay, wait. Okay, now we have some checked. So I think this is the best you can get for now. It's working fine, so I don't know what they want anyway. So yeah, so that's it. So let's just ask for correction. So by the time you finish this, you should be getting like 20 something percent, maybe 20%. And in total, if you're doing it for the first time, like first deadline, you should be getting like 140%. Okay, so basically that's it, and I'll see you in the next class. Bye.